Alright, so we're gonna get into solving using elimination. Again, elimination could vary. Sometimes it's pretty much already set up for you, sometimes it's not. The point of elimination is to either eliminate the x value or the y variable. Sorry, the x variable or the x variable. And that it's pretty much totally up to you. Alright, so let's see how can we decide which one to eliminate. Well, if we look at this system of linear equations, let's first look at the x value. So I see that I have a 5 and I have a -4. Now, the point and the first step to eliminate is to make those two coefficients, meaning the numbers in front of the variables, to make them equal the same but opposite signs. In this case right now, I do have opposite signs. I have a +5 and I have a -4. But they are not the same number. I have a 5 and I have a 4. Now, by using multiplication and keeping the equation equivalent or balanced, I can make those two numbers the same. Now, I can multiply 5 times 4 and make it a 20, and I can multiply 4 times 5 and make it a 20. Now, that seems like it's going to be a lot of work because now I'm going to have to multiply both equations. And imagine multiplying 4 times 14 and 4 times 25. That's going to give you huge numbers. So I'm going to go ahead and look at the y's. I see that they're also opposite. So I have a -14 and I have a +7. I can see that to make them the same number, all I have to do is multiply the 7 by 2. And I don't have to do anything to the first equation. So that sounds much, much, much better. So I'm going to go ahead and do that instead. Okay, now that means that I have to make that 7 into a 14, so I have to multiply everything because you want to keep it equivalent. You can't just multiply one number because now you're changing the whole equation. So I'm going to multiply everything by 2. Alright, let's see what we get. So I'm going to take the top equation, which is 5x minus 14y equals -25. And now I'm going to multiply the bottom one. So I get -8x plus 14y equals 40. Okay, so now I can go ahead and eliminate. And how do I eliminate? I'm going to be adding the equation. So I get 5x plus -8, which is -3x. I get -14 plus 14y, which is 0y. And you don't even have to write the 0 if you don't want to. And then I get -25 plus 40, which is 15. Alright. So now I only have one variable. I can go ahead and solve for x. I can divide -3, -3. That goes to 1, so x equals, -5. Cool. So now I know the value of x. I can go ahead and start solving for y. And then again, same steps. You're going to pick one of those two equations and you're going to input -5. Actually, I'm going to go back to this. It doesn't really matter which ones you choose, the originals or the ones you multiply by 2. They are the same thing. They're all equivalent. So I'm going to pick the one that is probably less difficult. I'm going to pick the second one, the original one. So that is -4x plus 7y equals 20. And I'm going to substitute x equals -5 for that x right there. So now I have -4 times x, which is now -5, plus 7y equals 20. And now I can go ahead and simplify it and solve. So this is going to be -4 times -5, which is 20, plus 7y equals 20 minus the 20. Cool, this is going to be great. So that is 7y equals 0, which makes it so much easier. Still divided by 7. So y equals 0. So the solution to the system is -5, which is the x, comma 0, which is the y. And if you remember from Algebra 1, the solution to a system is the order point that makes both of those equations true. All right, see you later.